In this video, I'm going to talk about the trigonometric identities, or we call that fundamental trig identities. Okay, I would like to remind you a while ago when we learned this. This is x, this is y, this is r, and here's the angle theta. Do you remember sine theta? That would be y over r, and a cosine theta, which is x over r, right? That was we learned in the previous chapter or unit. And then tangent theta, did you notice that is y over x? So which is actually y over r over x over r, and that would be sine theta over cosine theta. So tangent theta is sine over cosine, sine theta over cosine theta. This is one of the identity. We call this as an identity. So we're kind of like moving around between all those trigonometric functions. And we're going to learn more about that, and we call them all identities. So I will tell you something that I learned a long time ago when I was in high school. I think I have never seen that in other places, but I believe they're very useful. So I would like to do this: sine theta, cosine theta, tangent theta, cotangent theta, secant theta, and cosecant theta. And then I ask you to draw me this graph. Okay, it looks very easy, isn't it? It shows all the 6 trigonometric functions. Okay, so with all of those, and the middle one is 1. Okay, I'm going to put this shaded triangle. Okay, as long as you can remember this graph, I usually put a bar here, bar here. Okay, I will explain this. And then you're going to use this one to remember all the fundamental identities. Okay, first of all, I think I call that rule number 1. If you have item A, item B, item C, like 3 items, all consecutive to each other, all next to each other, so A to B to C, and then you're going to have A equals B over C. So A is B over C. Backwards also worked, so C will be B over A. Or the 2 at the end multiply, you get the product, which is the middle one. So B is AC. Okay, so this is my rule number 1. Not bad, right? Okay, what does that mean? So A is B over C. Did you see this? Tangent is cosine over, tangent theta is a sine theta over cosine theta. You see? So that agreed with what we just talked a little earlier. At the same time, cosine theta is a sine theta over tangent theta. So you can not only go this way, you can also go backwards. And then the same thing, sine theta is cosine theta over cotangent theta. Cosine theta is cotangent theta over cosecant theta. Okay, backwards. Secant theta is cosecant theta divided by cotangent theta. Sounds very good, right? And also secant theta times the cotangent theta is cosecant theta. So that is this part. That is the B equals AC. So ABC, the 2 at the end, multiply, you get the middle part. So secant theta times the sine theta, you get a tangent theta. So this is very useful. And not only we can go around this, we can also go straight, like a tangent theta is 1 over cotangent theta. Cotangent theta is 1 over tangent theta. Sine theta is 1 over cosecant theta. Cosecant theta is 1 over sine theta. Secant theta is 1 over cosine theta. Cosine theta is 1 over secant theta. So for this, they can remember they have 2 identities. One is called reciprocal identities, which is sine theta is 1 over cosecant theta, and cosecant theta is 1 over secant theta. But actually, I don't want to separate this reciprocal identity to with the called quotient identity. I think as long as you remember this rule, then you remembered everything. Okay, so that's a number one. And number two, if you have A, B on top, and C at the bottom for the shaded triangle, you see that I have three of them. Then the A square plus B square will be C square. So let's see, sine square theta plus cosine square theta equals 1 square, which is just 1. So what we have here is a sine square theta plus cosine square theta equals 1. Very similar, we have tangent square theta plus 1, which is 1 square, so I just write 1 equals secant square theta, and 1 plus cotangent theta, which is this shaded triangle, that will be cosecant square theta. Interesting, isn't it? Okay, the very last one is do you remember let me just do this. I put two underline, two bars under cosine and secant because they're even. Okay, and all the others are odd. Do you remember what is odd and even? For even function, f of x is the same as f of negative x. For odd function, f of x equals negative f of negative x. Okay, so cosine theta and secant theta, they are even functions, which means the cosine negative theta is the same as cosine theta. All right, so that's why I put this two underline. And then all the other four, like a sine negative theta, because that's an odd function, that will be negative sine theta. Okay, see the difference between these two? All right, so as long as you know this, I would like to mark this in red because this is so cool and it's so important. I only need to remember this graph, and then I can remember all the basic identities. So that's what we are going to use this to prove or to verify a lot of trigonometric identities, which is going to be the next section.